Have you guys seen all of those freshly installed whiteboards outside my office now? It is so nice. There's so much room. And now when people are working on their combinatorics homework, when people are working on their combinatorics homework in the on the whiteboards outside my office, then before I go home at night, I can come out, take a look at the room like I did last night. And I looked at the one board and I said, "Oh my God, that's all wrong." But then, of course, I didn't know who wrote it on the board, so I got out the red marker and I went over there and I circled it. And I said, "This needs fixing. Please see Dr. N." So nice. You're getting editing of your work even without realizing it. So anyhow, I think that was yours actually. And I think Amber helped you fix it. So I think you're good. Anyway, welcome everybody. It's great to see all of you today. Quick couple of announcements and then we will just kind of wrap up this forbidden positions thing with a couple of examples and a little bit of group work. There is a homework assignment due tonight. As always, I have office hours after class. I'll be down there for a long time. Just take a dinner break around 7 for an hour or so. Other than that, I'll be in late into the evening. If you want to ask me anything, you can come in Zoom, you can come in person. But try to get that homework in tonight. I'm going to try to grade it within 24 hours or so. And that'll kind of be a wrap on everything heading into our midterm. So just to remind you again, next Tuesday, you'll have the whole hour and 15 minutes. I'll probably try to give you an extra 5 minutes just in case you need a little extra time. Try to be on time, obviously, so you have the full amount of time. So that's next Tuesday, October 8th. And it's, I've obviously already talked to you about the resources folder that reviews what you need to cover for the exam, kind of which chapters, which topics and stuff like that. So I won't go over all of that again. I do want to remind you that I'm going to do a couple of reviews. These are optional. And I will record them. Again, no promises that it's the world's best recording ever, but I will at least have my audio and hopefully decent video of this. So one of them, I'm going to do it tomorrow evening. And again, I'm doing them in the evening just because that's the best chance that there's more people actually free and not working. But I know that that's maybe not a perfect answer, but it's the best I can come up with. I am going to repeat the session also on Monday. So Friday and Monday, more or less very similar sessions. If you can't come or don't want to come, that's fine. I'm going to record the session and post it out to you guys. I'll send you a link in the email. You also can come in Zoom and just hang out from home. And I'll have my camera here. You can ask questions, whatever you need to do during the session as well. So this will just be the way I do review sessions usually is just practice problems. I mean, I'm not going to like review everything from the beginning in as if I was giving a lecture. Obviously, I'm going to pick practice problems that will hopefully cover the span of the material and give you a practice on a lot of the topics that I'm likely to put on the test. I won't be writing the test until after Monday night at 7 because I like to be able to come into my review sessions and just be totally free flowing with everything I want to say and try to be as helpful as possible rather than kind of having to watch what I say and then, oh, let me not give away the exam, that kind of thing. I don't like that to do that. So anyway, so I won't be able to say much about that. But as you know, there are a couple of sample midterms in Canvas. So you'll get an idea of what it might be kind of looking like if you take a look at that. Okay, so anybody have any questions about that? Yes, go ahead.
When you say repeat the session, do you mean like the same exact problems or are you gonna do like different ones?
Okay, so what I have probably too many problems to do them in just 2 hours. So I'm going to only go for 2 hours though. So after I cut off on Friday, there may be some that I didn't cover. I will probably start with those on Monday and then cycle back to the old ones again a second time through. Yeah, I'll try not to make them exactly identical. Obviously, it'll depend a little bit on what questions people have and that sort of thing. I'll probably go in somewhat of a random order also. I won't be doing in case you're wondering, after the fact, oh, is he just gonna start from the first week and go directly down in order of weeks? Probably not. I'll probably jump all over the place because that's probably how people think about exams as well. Yes, question, Alyssa? Oh, which Zoom link is it? Let's use the one for the class, because otherwise the 250B people could come in the middle of the session and they'll be like, I want to ask a question. I'm like, no. It's not now. So, let's use the classroom Zoom. I have to prioritize you guys. You guys have a test overseas. So, okay. All right, any other questions? Okay, great. So anyway, we're basically done with the material for the exam. The only thing that's kind of a loose end, I guess, is I stated this theorem about forbidden positions on Tuesday, but then I ran out of time to actually do an example, and I want to do one. I actually want to do 2 examples, and then we're going to do some group work and let you guys practice this forbidden positions theorem. Remember, this is kind of just a generalization of the derangements idea. Derangements would just be a forbidden positions problem where the forbidden positions are right down the main diagonal of the square. So this is just generalizing that to like any setup of forbidden positions. So I've got a little example here. But before we get to the example, the main tool that we're going to use to solve the example is this theorem right here. So I wrote it down last time, but I want to kind of talk about it a little more right now. The number of solutions to the forbidden positions problem is this formula in the box, most of which is pretty clear. Obviously, you've got these inclusion, exclusion terms with factorials. That's easy, right? But I want to talk about these R's. So you see I've got R1, R2, R3, these various numbers here. Those are just numbers. And so here I've tried to explain what those variables mean. R sub I is the number of ways to have a violation, because we're really notice that we're subtracting violations here. It's a violation in at least I of the positions. So R1 would be the number of ways to for sure have at least one violation. And remember that the positions, at least the way I was drawing the diagram earlier, are corresponding to the rows. By the way, I should mention that if you were to take a word problem and then draw the corresponding grid for that problem, let's say that, you know, you put the people down this way and then you put their hats up this way, right? The hat check problem. It would be actually okay if you had put the people across the top and the hats down this way, so that, you know, if you flip this grid so that rows become columns and columns become rows, you will get the same answer for like how many, you know, solutions there are to the problem. So you don't have to get worried about that. Sometimes people ask me, well, how do I know whether to put the X's on the rows or on the columns? Well, it doesn't matter. It actually does not matter. So you can get away either way. So here, but the way I'm doing it, I'm doing the positions here kind of row by row. So I've got 5 of them. And so R sub I is the number of ways of having a violation in at least I positions. When I say at least I positions, what that means is that you're going to require that there are some violations. And then after that, let's say that, let's just take a quick example, I equals 2. Okay, so you're going to require that there are 2 positions that have a violation. That could be the first 2 positions, potentially, right? So maybe I choose this one and I choose this one. And then after that, you have 3 more positions and 3 more columns to choose. That's where the 3 factorial would come from, n minus 3 factorial. So, right, because I is 2 right now. So the R sub I term would correspond to n minus, R sub 2 would correspond to n minus 2. So that would be 5 minus 2, which would be 3 factorial. Do you see the 3 factorial? You have 3 more rows and you have 3 more columns. You got to pick one dot in each row and column. Well, you could in the remaining 3 rows of columns, you might have to actually choose another X. That's why it says at least I positions, okay? And that's why we're having to do the inclusion exclusion, right? Because it's possible that some of these things are being counted multiple times. By not dictating whether you're going to choose another violation or not, that's why you get away with just the 3 factorial. Is like, I have 3 rows and 3 columns, I'm gonna pick dots anywhere, I'm not gonna worry about whether that was a violation or not, I'm just gonna allow everything. And so that's why you, in the formula over here, you just see those factorials there, with no additional considerations having to go into it. The considerations that go into having maybe overlapping scenarios is already baked in to this formula. You see, the inclusion exclusion has already been put into this formula. Okay, so with that in mind, I think it all makes more sense once you've done an example. So let's figure out what R1 through R5 are on this. Obviously here we have n equals 5. And so we're going to figure R1, R2, R3, R4, and R5. So this is really where the main work comes from. So what is R1? Number of ways to violate at least one position. So I'd like to decide which position it is that's going to be violated as a guaranteed violation. And it could be position 1 or 2 or 3 or 4 or 5. I'm not really drawing slots like we normally do for permutations. I am just going to add up all of the ways to have a violation either in the first position or in the second position or in the third position and so on. How many ways are there to create a violation in the first position? 3. It's 3 X's up there. I'm going to put 3, but remember the violation, this does not say that the violation occurs in the ith position. It just says that there are at least that many positions. So it could be the first position, but then there's also the second position. How many violations could there be in the second position? 2, right? And how about in the third position? 1. And how about in the fourth position? Nothing. And the fifth position is nothing. So that adds up to 6. And just as a remark, just so everybody's totally clear on this, R sub 1 is always the easiest number to figure out because it is just the number of X's in the entire grid, right? So it is the total number of X's in the picture. That's it. That's going to be it. The total number of X's in the picture, that's R1. Okay. All right, so we get 6. Now, what about R2? Now, R2 is the number of ways of having at least 2 violations. So I'm going to decide, well, where are the 2 violations? It could be in rows 1 and 2, positions 1 and 2, or it could be positions 1 and 3, or 1 and 4, or 1 and 5, or 2 and 3, 2 and 4, 2 and 5, we have to write them all out, 3 and 4, 3 and 5, or 4 and 5. We have actually 10 different ways here, right? And we're gonna, again, add them all together. So that's just a nice way of labeling the different positions that we're going to have. And now we're gonna try to figure this out. Let's talk about violations in positions 1 and 2. Okay, now this is where you have to start being careful with it. So I can, remember, it's already pre-assumed you're not putting 2 dots in the same row or column. Can't do that. So like in this first and second row, if I choose this dot right here, then I cannot choose the one right below. So, but I have to choose a violation if I'm doing the 1, 2 position here. So if I choose this dot, then I have to choose that dot. That way I violate both of the first 2 positions. But I could have chosen this X in the first position, and then I would have had 2 more ways of choosing a violation in the second position. Or I could have chosen this X, and then I would have had 2 more ways of creating a violation in the second position. How many total was that? 5. That was 5 ways so far. That's just the first term. That's just the first one. Does everybody see that? I can take this X together with this one. Or I can take this x with either of these two, or I could take this x with either of these two. Okay, can't imagine trying to teach this without the picture. Anyway, so that's positions 1 and 2. What about positions 1 and 3? Because that's the next one that we're supposed to look at. So 1 and 3, I have to pick this x. That's the only violation I have there, which means I cannot pick the one directly above it. So it's this x with either that guy or that guy. 2 ways, right? I will start going a little faster, but I'm just trying to make sure everybody's getting it first. This is totally a little fun game with this picture of x's, right? What about 1 and 4? How many ways are there to be? How many ways would there be to have a violation in rows 1 and 4? 0. You can't have a violation in row 4, right? There's no x's on row 4, so you can't make a violation out of that. We're talking about how many ways to violate these positions. I can't violate the 4th position. I also can't violate the 5th position. So anything that involves 4 or 5 is a 0. All right. We can get all those numbers down right away. So I only have one more to do, which is 2 and 3. And how many violations for 2 and 3? I have to take that x with either of these two x's here. That would be 2. Okay, great. So that adds up to 9. So the unfortunate thing about this is that it gets harder the bigger the I value is. When we go to R sub 3, it's going to get a lot harder, except there is one bit of good news. The only term that doesn't have a 4 or a 5 in it. Remember, if row 4 or row 5 is involved, you can't make a violation. So all of the rest of these terms are all 0. I won't write them all out. It's just this one that we have to figure out. Okay, so let's look at 1, 2, 3. I'm required to make a violation in all 3 rows. Okay, so I have to pick this x. Maybe I can. It gets once it gets to be a bigger value of R, you almost need something to keep track of it. So I'll draw a blue dot there. And now, so I have to pick that. So that means I can't pick this one. So then what do I have left in the first 2? I can take this one, these 2 here, or I can take, right? Can everybody see this? These 2 here, or these 2, or these 2, or these 2. That should be 4, right? Is that what everybody's getting? You're picking this one for sure, and then you're either taking this one with this one.
Or the other one was one.
Oh, did I say?
Yeah.
I'm sorry, it should be 5, right? Oh, 3. Yes, 3. Okay, let me say it again. I can take these 2, or these 2, or these 2. 3 ways to make a violation in all 3 rows. That would be a 3. So let's write that down. Right there. And there is no way to have 4 or more violations because you only have 3 positions that have any violations at all. So what you would do here is R4 equals 0 and R5 equals 0. You don't even have to think about those. Yeah, Nikolai?
If you had put down the box differently, and if you looked at the 3 degrees.
Uh-huh.
then you'd have-
It might be harder to come up with some of the numbers then. So as I was saying, it wouldn't affect the answer to the problem. But then, like if I flip it the other way, I can see 1, 2, 3, 4 different rows that have X's in them. So you'd have, you'd actually get something here, right?
Would it be easier then to rotate the box?
Hmm. I should do that for the test. No, I'm just kidding. Some good ideas. Let's make it really horrible the way it's set up and then, no. We'll go all the way. Okay, so let's get the final answer here then. The final answer would be n factorial. That would be 5 factorial minus R1, which was 6 times 4 factorial. And then plus R2, which was 9 times 3 factorial. And then are 3, which was minus 3 times 2 factorial, and then the rest of the terms are 0. So it's plus 0 and a minus 0 at the end. It's gonna look like that. Okay, so that's equal to 120 minus 24 times 6, I think, is 144. And then plus 54. I wouldn't even necessarily ask you to simplify this. You could just leave it unsimplified. I just actually want to get an answer out of this. So that's I think that should come out to 24. That should come out to 24. We could actually write them down based on the diagram, right? So we could make a list. I think I will do that just to show you. So like in the first position, you have to have either a 2 or a 3. Right, so you could start with either a 2 or a 3. We could do all the ones that start with 2. So let's say let's go back here. I'll undo my dots. I just kind of want to confirm our answer, right? So if we picked this dot here, that's acceptable. Then what do we do from there? Well, then I can go to 4. I can go to 4, and then, so if I pick 2 and 4, then I've got to do either 1, 3, or 5, and now I can do all combinations of those. 1, 3, 5, I can do 2, 4, 1, 5, 3, 2, 4, 3, 1, 5, 2, 4, 3, 5, 1, 2, 4, 5, 1, 3, and 2, 4, 5, 3, 1. Those should all be okay. All right, so that's 6 of the 24 are just doing that. But then I could have said, well, what if I did 2 and 5? So I could do 2 and 5. So if I start with 2 and 5, then what's possible? Then I could do, well, I can't do 1, 3, 4. So I can't have, I can't choose a 4 next. So I can go with a 1, and then 3, 4, or 2, 5, 1, 4, 3. Or 2, 5, 3, 1, 4, or 2, 5,
1, 3, 4.
3, 4, 1. Yeah, 3, 4, 1. I'm trying to do them in increasing order here. So all of those would work, but I can't do 2, 5, 4. So I think that's all the ones that start with 2. Okay, and how many do I have there so far? About 10. So then the next step would be, well, what if it started with a 3? So I'll do those in the next column. It start with 3, and I could go 3, 2. I'm kind of going in numerical order. 3, 2, and then the numbers I have left are 1, 4, and 5, but I can't do a 4 next. So I could do 1, 4, 5, or I could do 3, 2, 1, 5, 4, or 3, 2, 5, 1, 4. Or 3, 2, 5, 4, 1. I can't put a 4 in the third position, right? That's the key thing here. You should never be seeing a 4 in the middle position. So that's one choice, but then I could also have done 3 and then 4, and then I have the numbers 1, 2, and 5 that can be in any order, right? So I could do 3, 4, and then 1, 2, 5, 3, 4, 1, 5, 2, 3, 4, 2, 1, 5, 3, 4, 2, 5, 1. I hope this isn't boring anybody. Write these all down like that. And then lastly, we could start with 3 and then 5. Okay? So we can start with 3 and then 5, and then we can't put a 4 next. So now I've got to do 1, 2, and 4, but I can't do the 4 first. So 1, 2, 4, 3, 5, 1, 4, 2, 3, 5, 2, 1, 4, and 3, 5, 2, 4, 1. I think that should be everything. Are there 24 things there?
Yeah.
There are?
I was counting as you.
Oh, I appreciate that. Thank you. Yeah, there should be exactly 24 things there, and that is consistent with this answer. Okay, do you want to try one more? Okay, let's try one more together, and then I'm gonna give you guys a group work and let you try it on your own.
Use
Simple.
Can you make quick penguins?
How many solutions?
Oh, yeah.
for positions. Problem.
Bro, there's penguin, it's penguin, yeah.
So let me give you one more, and we'll do this one pretty quickly. This is just a 4x4, but I am gonna have quite a few X's in it. So that does make it a little more interesting. So it's a 4x4. I'll put X's here in the first two positions of the first row. And then in the second row, the second and fourth spots. Third row, just in the fourth spot, and then in the last row, the first and third spot. So I'll make this little grid like so. Okay? And so let's just practice this one more time. Okay, this time n is 4. And so I'm going to be trying to figure out what R1, R2, R3, and R4 would be equal to. So let's start with R1. Can somebody tell me what R1 is? The number of X's in the total grid is 7, right? So R1 is 7. For R2, there's going to be several terms. I'm going to imagine doing violations in pairs. So positions 1 and 2, or 1 and 3, or 1 and 4, or 2 and 3, or 2 and 4, or 3 and 4. Those are the 6 different ways of choosing 2 rows to create violations. How many violations would there be in rows 1 and 2? So if I choose this violation, then I have 2 here, right? Or if I chose this violation, I only have 1 way to do it, so that adds up to 3, right? Got 3 there. Okay. Then how many violations would there be for rows 1 and 3? 2 of them, right? Okay, looks good to me. How about violations in rows 1 and 4?
3.
Should be 3 of them again. All right, how about violations in rows 2 and 3?
Find out.
Only one way to do that, because I have to pick this X, which then means I can't pick that one, I have to pick this one. So that's only a 1. How about in rows 2 and 4?
4 and 4.
Yeah, I've got 2 X's here and 2 X's here, and they are not in the same columns, so I can mix and match them however I want. That would be a 4. And what about in rows 3 and 4?
2.
2 ways to make a violation there. I have to pick this X and then either one of these 2. Okay, great. So what's that add up to?
15.
15. Great, 15. Okay, let's go to R3. So now we have to do 3-way violations, either 1, 2, 3, 1, 2, 4, 1, 3, 4, or 2, 3, 4. Make sure you don't miss one of these, by the way. Make sure you get every combination of 3 rows. Those are the ones you can have. So let's look at rows 1, 2, and 3. How many violations would there be for rows 1, 2, and 3?
1.
Have to pick this X, which means I have to pick this X,
Which means
which means I have to pick that X. There's only one way to do it. So that's a 1. Okay. Now let's look at rows 1, 2, and 4. Okay, so this is a little tricky. Row 1, 2. The way I like to do it, you can think of it as 2 cases. One case where you choose this X, and another case where you choose this X. So rows 1, 2, and 4. Let's say I choose this first X right here. Okay, so now I'm looking at rows 2 and 4. I've already chosen this X, which means down here in the 4th row, I have to pick this X,
And you have to.
right? And I can pick either of these 2. So that's 2, but I'm not done because that's if I pick this X in the first, this violation in the first row. Let's go back. What if I picked this one? Then I have to pick this one, right? And then I have 2 choices down here. So there's actually going to be 4, and that's all just for that number right there. Okay? There's nothing like that super technically complex about this. It's just kind of got to be focused on it and be a little bit careful. 1, 3, and 4. So for rows 1, 3, and 4, obviously I have to pick this X. And then out of the first and 4th row, I would pick, well, either these 2, or these 2. There would be 3 of those. Okay, so that would be 3. Right?
I think I got 3.
All right? So I have to pick this X because I'm using these three rows. So I have to pick this one. And then in the first and fourth rows, I just can't use this combination. But I can use this one, or this one, or this one. That look okay? All right, great. So that's 3. And then finally 2, 3, and 4. Let's see, violations in rows 2, 3, and 4. I have to pick this X, which forces me to pick this one. And that leaves me 2 here. Right? So that's plus 2. What's that add up to? 10. Okay, we got 10 for that one. Finally, R4. It actually is. There are X's in all 4 rows. How many ways are there going to be to have violations in all 4 rows?
What do you have to fix?
I have to pick this X,
Yeah.
which forces me to pick this X, which forces me to pick this X, which forces me to pick this X. Sorry, there's only one way. By the way, this number cannot be bigger than any number that you've seen already. So like, there's already been a 1 here. So even just trying to create violations in rows 1, 2, and 3, there's only one way to do that. So if you add a 4th row, you can't suddenly have more ways of doing the violations. So it can't be any bigger than anything that you've had up until that point. Are you okay back there?
I was
I
just
see
gonna
you-
see if, for the 3 combination of 1, 2, 3, so when I was doing, I got 6.
1, 2, and 3. So the reason it's only 1 is you must pick this X in row 3.
Oh, okay.
You must pick it. And because of that, you can't pick this one because remember, you can't have 2 dots in the same row or column. So you must pick this one. And then that forces you in the first row to pick this one. So you have a bunch of forced choices and you actually only have one way to do it. Yeah. Okay, so what's our answer going to be here? Let's see, 4 factorial minus the answer. Just want to see what this is. 4 factorial minus R1, which was 7 times 3 factorial. Then plus 15 times 2 factorial. Then minus 10 times 1 factorial. And then plus 1 times, well, it would be 0 factorial, but you don't need to write that down. So plus 1. So let's see, what does that give us here? That's 24 minus 7 times 6 is 42. And then plus 15 times 2, which is 30. And then minus 10, and then plus 1. Those are the numbers that we have there. And I think that is equal to 3. I think it's equal to 3.
Yep.
So actually, we ought to be able to write them all down. There's only 3 of them. Yeah, no, you don't have to. You could leave it in the ways that you have it on the first line there. This is more like if you wanted to check your answer. Does it make sense here? So how could we get 3 solutions? So here's one. That's one way to avoid all the X's and get a valid solution. How else could I do it?
You can move the upper weight on.
Yeah.
Move this one over here.
Oh,
And the last one.
oh, yeah.
Then this one has to go here. And then this one, oh, I could go either way. Or I could do, these are happy faces.
Oh, no.
Something like this, right? That's how that, yeah, something like that. So that's the only 3 ways there are to do that. Okay, you guys think you get it? Everybody get it? Let's take a few minutes and let you guys practice. I've got a group work here. The other thing I should mention is, the problem might not be just, here's the grid. The problem could be, oh, we have Johnny and Jackie and Jerry and Jimmy and Joey. And Joey can't have these stuffed animals, and Jerry can't have these stuffed animals. So it's a word problem. But usually people can recognize, oh, this is forbidden positions. It's just like he's doing it as a story problem. So I have one on here that's kind of an example of what one of those story problems might look like. So I will pass this out and let you guys go to town. And the last two problems on the homework for tonight are just doing these forbidden musicians problems, so it's not too bad.
Dr. Anna,
Yo,
can you put another penguin problem on the test?
you want another penguin problem? I think your classmates might have something to say about that. Okay, guys, go ahead, we can use the mic.
There's a pink.
You should make. forbidden
Yeah, there's a pink up here.
Every time you like today.
Say yes. All right, well,
Daniel Jose, now I have Abba stuck in my head.
What?
I had so far stuck in my head.
perfect. This is gonna get you back in office.
I am glad that you have it.
Yeah. It's the same, but same. And stuff like that, like, you know, how to. When you're patient, when you're just so mad that he doesn't, it's easy then, because you're already. Yeah.
Okay, I might do that.
Yeah.
I appreciate it.
It's like, Here we go. It was like, I learned for us. We saw.
For the season to start. For games within a month or so. Yeah, I'll try to come to some of them. Yeah, yeah, I'll try to stop by. Luke, who are you working with? You're with them? Or let Khalil can work with you. Yeah.
Are you doing the second round? Problem,
I have to figure out where my answer key is.
Wait, that is. No, because they're. Yeah.
Yeah.
Would be the other. Property, right? So then what is that? And then you want it to be one. Or am I so? The top three would be. Oh, yeah. When someone's on. Oh, yeah.
Yeah.
Let's do these ones, 1 and 2. One and two is
No.
Wow, I can't believe it's.
I know, Doctor.
Didn't work, it's a word, I can't see it. That's okay. What did you get? Right. So I got a number of figures. Your partner.
The forest fair had 20. Pretty rangy. Why'd you get three? No, we had proposing.
I thought you were.
Yeah.
You have to be really careful. Keep in mind too.
The only one that we're working on.
Spend like 30 minutes just working on the computer. As long as you have the idea of it. That's pretty okay. It just checks the numbers here. On 1 and 3, 21. So far, so good. Great job. What did you guys get for R2? Oh, this is on the second hole. Or they're doing.
Oh, and so like those are really. Also. Yeah, okay.
This is the.
Then we get.
Oh, I know it's Robin. I know it's Robin. Only done the combinations that have one. Oh, yeah. Yeah. There's actually wrong. Oh, yeah, yeah, it takes a little while.
So it's only gonna be 1 to 3 million.
I did.
I'm thinking, I'll feel like.
Oh, you can talk about a much better number. That's right.
There's 10 here. Okay, sure, you for. No, just when. Just one or the two.
Yeah.
Just one, thank you, 3, 1. Offer more.
No, I didn't.
Yeah, 1, 2, 3.
Oh, yeah.
Big baller, 5, 6, 7, 8, 9, 10. Yeah, go 1. One, two, three.
Alright. Or I say yes, so now that we're saying one way.
Yeah. Yeah.
That's right.
Oh, wait, sorry. Yeah, yeah.
Oh.
You don't eat those things.
Three to meet. Any number of.
Yeah.
What about the rest of the? Anything, R one, what about R four? Okay, so that should come out. No,
Yeah.
What's right? Two. Oh, no. Let's see. You messed up somewhere.
I got 21. I don't know what they did 20, but you did 21 and they got 20.
No, I.
We all collectively got 21. Oh, alright.
So I would just let it go. This is pretty close. You're probably not going, why don't you keep working on it?
Approximately 21.
Approximately 20. Yeah. Like one more. All right, nice. What does this have up there?
Oh.
That is actually not twice in the rest.
You're missing something there.
Maybe we missed like a one of the. You know what's hard? You know what's hard? Keeping up how many chunks. How would you know how many chunks you would have? How would you know how many chunks? Yeah.
Chunk, you just a little way that you can. You'll come in.
Okay, but like,
How do you know?
how do you know how many? Where? He know, like, yeah, he was doing it, he's like, oh, it should be.
This one, just to the, it's inches case. So you got one. So like. You have 6,000, you're gonna choose how many ways can from you go 50. Right, 2 sticks. 6 choose. 6 choose in the middle. So it's like, it's done something. You know what I mean? That's why they have 6 choose 6. Yeah, wait, Dr. Annan, I have a question real quick.
Please.
So you know how we're always trying to find like the ways like 1, 2, 1, 2.
Yeah.
The number of those that you should have is always just gonna be like choose K, right? That you
That's exactly right. So if I'm doing.
You should
I can
choose 3.
Deleted row 5 because. Terms there, then it would only be 5 choose 3. But the way they did it, 6 choose 3, which is 20. So they should have 20 terms at least.
I think that's.
19.
I told you.
I told you. That may be why I only got 20. There's something missing and I bet I'll be able to.
Let's see, 1, 3, 1.
Dude, I was
3,
like.
4, 6.
3, 4, 6.
Yeah, for this one, do it.
Is it 1? Yeah. That's where the 21.
Yeah, there you go.
Look at that, man. Yeah. Try to write them, it's good to count how many terms there should be, and writing them in numerical order is a good idea too. If you start randomly trying to write down any 3 numbers, you'll miss something.
That's the one thing I noticed, like, how do I keep track?
Yeah, so try to write them in, so all the ones that start with 1, if those first, all the numbers are in increasing order. And then do all the 2s, and then all the. There's 20 numbers, yes. If we do the 6 choose 3, which I think that's 1. Yeah.
Alright.
That's right.
Yeah, and I just want to make sure that whatever's saying was correct.
Exactly.
That's like the last one is always the
6
way,
choose
it's 6 choose
3,
3.
50.
The last one's always 1 wrong numbers in the system. That's why you have 1, 2, 3, 4, 5. It's only one watch. There's only.
You got some more terms. You gotta give him another chance. Oh, this is hard, you know.
What should help you know is of the particular cases that you have to run to, you'll always have things A on the top number. So you don't know that you're. So if you're missing. But there's not a way.
Okay.
Even the audio one. It's just the one you want. And then you have to predict it. I don't know what the rules are.
Wait, actually.
Yeah. I'm just gonna pick on you, put them, you know, 1, 2, 3, 4. Let's do it. There's 6, and then like, how do we start? Which spine? Why do we don't do like 1? Why did you not? You know, well, that's. Like, you just. What's the first place? But that's the thing. Just start with the 1, 3, 5. Okay. You actually find it. It's so confusing how to keep track of like this. People did, but I did. There were. Yeah. And that's the last one, but now you need to do what time with three, right? And that's. So do 1, 2, 3, 4. You been to her? Yeah. You have the second one? Well, we're there over there. No, I didn't do anything. I was just waiting. Okay, everyone do it. Let's see if we can get the same answer.
Yeah, I think we're done. I would say
Where should we left? This one? That's me. It's actually would be different or not.
Alright, once you check your work.
We have to put this one up. Yeah. Let's say. 1, 2, 3. It is real. We have to pick this one. If we can pick this one, oh yeah. I think people are fighting. You know what that do? That's the fight there actually. Excuse me. Oh, yeah. 1, 2. That's 7. I got 15 cases. But. Well, for a lot, so they don't like food. I mean, I think it's only food right now. That's working. Big TV. For 1, 2, 1, 2, 3, 3. So 1, 2. Let's just pick that one, right? Pick this one, right? And then we should pick this one. Then we can. That's one.
Thank you.
Then we take this one. Pick just one away, right? 1, 2, 3.
Yeah, no. Nah, it's good to get. Oh,
I keep forgetting. It will be helpful if I just cross. That's manual. What? I think it would be helpful if I just cross it out.
What did you guys get for 2, 3, 4, 6?
Oh, we're not there yet.
Okay, you're not there yet. Oh, I'm sorry. Okay, okay.
No. 2, 3, 4. I pick this one. I can't pick this one. I have to use the pen. 1, 2, 3.
Wait, you want no, because it's this one, right, and then I'm gonna have to pick this one. Right, you can't pick this one anymore, so you have to pick this one. Right, and then you already like swap. No, but you don't know, you can't, can't.
Wait, 1 and 2.
Oh, no, dude. Two. We are not here. I said it leads to, but we should also use something again. No, I'm looking at
But it's absolutely. I think that one.
Huh? 1, 2.
I did it.
One of these ones. Okay, we gotta go back.
I think it's probably this one. That one, and you have to pick that one. You have to pick that one. It's good choices, right? I think it should be two. So then that gives you the. Okay, awesome. Good job.
I'm not bringing multiple, like, from your hands.
Yeah, it might be helpful. I think it's good.
Alright.
Because then you know.
Dr. Allen, cheer coach.
Oh.
Yeah.
That's right.
Yeah.
Hey, guys, can I get everyone's attention here? I think this is going pretty well, except I had a typo on my solutions to one little thing, so I was getting the wrong number, but I'm seeing lots of good numbers around the room. I've kind of been checking out. Does everybody kind of get the idea behind this? Kind of, you just have to, recognize that it's a forbidden positions problem. And then from there, you can go through these R1, R2, R3, R4 calculations and so on. So we only have 15 minutes left. I don't really feel like starting a new topic since we have a test coming up. I think what I'd rather do, I have another group work. By the way, you might wonder where group work number 5 went. Actually, we had done those problems in class, so I just skipped over it. It is there. But I have another group work here that is more general review for the exam. So these are going to be actually counting problems again, how many ways to do blah, 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 blah. So I would like to pass this out and let you guys study for the exam a little bit. That sound like a plan? Unless you want to keep working on, if you're still stuck on the forbidden, you'll take 4, okay?
Everyone like that for like. What's this? You know what we
Yeah. Yeah.
Can we erase it or do you want to keep doing this?
Today. That's right. That's right. Thank you, Amber.
Great, I think that's like 1 to 6, isn't it just like 6 to 6?
They're the ones found in right? Yep. Yeah. So it's actually from the top 3, so you don't tell you the top 1 you create research. And then someone have a slide. And how many ones are the voice on the top 3 stories? You do it for last. Top 3 that will be the last.
There is no, I think 10 more.
Yes. Yes, please.
The rose.
You even got your basketball shorts on. I was like, well, let's go play.
Play that game.
We will, sir. We will, after the exam.
After I, you'll defeat it. Every time you miss a shot, you subtract from those.
So we'll give extra credit for the basketball.
Oh, I'll go. Everyone's gonna go.
Depending how you do.
We go there with the wait.
You guys know these people, don't you? You know them, yeah. Luke Holmes, Luke, all those people. Oh, yeah, for sure, for sure. Good stuff.
That's only three. Yeah, it's 2 points. You just do it. There's only 3 of them, that means they'll be. Does that mean that every second like? Morgan is 5-2.
You can transport the fact that, each type,
Yeah. And then the last one.
Yeah.
Are we just a living?
Oh, the multiples.
Papaya? You guys take some. Yeah. You like the smell?
You should be on one. Yeah.
What number is it?
1, 2, 3. So the reason is for 1, 2, 3, 4, you have to make this one, and this one. And now either. So it comes out to 8. It should just be 8. Clear enough?
Yeah.
Fantastic. Again, don't worry too much like some. Not gonna do perfection.
That's
like.
only the transfer value.
Somebody gets done these bars off by. It's not gonna make or break the test. Trust me, don't freak out.
Start with Mars and really.
Yeah.
That's just, yeah. That's just, yeah, that's the thing.
You don't have how many ways to make that we get 70 million, or how many ways to get 8. You want to get there.
Yeah.
Or you can tell. Yeah, that'll be good. Is that your three? I think people will ever opt for they like the thing. Like that. The thing like.
So these are like identical. See what I mean? So like all of it,
Like 3.
Right now.
There's more, 3 neighbor, 5.
Then.
You're off. 5 minutes. You're off. Right?
So A is the first If the first office is a violation. So we have to subtract violations on the opposite. What you have there, I think, Luke, is you're choosing 4 people to go into the 4 offices. And then putting more people into the offices after them. That's putting the people too much in order. So, start by just figuring out what if it was okay to have it middle works? And if there was no constraints and you just have 4 people being going to 6 miles, how many ways are there to be? There you go. That's how you want to start it off. Let's see.
Well, I guess they back it from me.
So, but before you start doing this. I can go into the same office that you can. So you have 6 choices for your office, so do I. Yeah. Everybody. And then we're gonna subtract the violations. The violations are the. That's it. Right there.
And then, so these 2 are empty, then it would just be. Yeah.
How many choices do you have?
So no way.
It's the office.
So mine is.
It's gonna be paid. Then. Find this. Yeah, four times in physics.
Yeah, it is.
That's.
What?
Oh, because there's a different times one.
Yeah, because it's tiny.
Because you don't, it's to be or it's like A, C, or B, or A, C, or E, or something, yeah. That's why, I mean, so for it's. Yes. And then that's one else with I guess, but I put that in.
That means they're all.
But think about it, think back to the question. Yes, it is, because they would all. Or no. No, they will support.
Oh, I didn't read that.
Right. I think this is. Like, yeah.
Anybody need a hand?
Yes.
Okay, well, after
Yeah, that was good. Yeah, much better. Oh, and number 3, looks good. Of course, on the exam, all of these will come with words, the plain, what the term, I don't just want to see the numbers there. I can see the justifications. This looks. Double check it. Yeah, looks good. Oh. Yeah, that's, yes, that should be as well. Yes, thank you.
And you have also. Even your.
I think I made.
Oh.
That one's great.
We have the same question.
Yes.
But they're
Yeah, I think I made a little.
Okay.
You check the answer.
Yeah.
I think that's what's really. Number 3.
Yes.
Oh, actually, hey, guys. Real quick, guys, I just noticed we're having so much fun. We've kind of come to the end of the time here. I just want to remind everybody that for both of these group works, I've got the answers up on the internet, and I'm gonna encourage you to review those on your own time. But I hope this was helpful. This group work number 7, guys, a couple quick comments. First of all, the group work number 7 is like really good practice problems for next week. And on group work number 6, sorry, going back to the R sub K thing. Some people were not getting all the term, like the right number of terms. Remember that for R sub K, there will be N choose K ways of like having K of the positions being considered. So that's one way to make sure you're getting the right number of them in your list, okay? Guys, I'll see some of you tomorrow, either in person or in Zoom or over the weekend, and definitely by next Tuesday. I'm here to help if you've got questions.
Or a little the homework problem where you would have to like do the A union B union A. But with that one, B's were not the same. No, I said the thing. This is right. First of all, wait for the intersect. Well, so you don't have to be intersect. That probably were different. Only the A, the cardinality of A and the cardinality of A and B. Things that we have, that are match. Yeah, they're more than all. That's right. Yeah, yeah, but.
Some people find that very not understand the
I think you're right though. Huh?
Example, they have their.
Okay. So it is zero. Okay.
So
Still want to say. No, it's.
the unit. So I have a solution on it. You take a look at it, then this is a good problem.
But then after he's like, here, expand it.
Is a.
Ah, I'll look at the solutions.
Thank you.
Okay? I'm gonna head on downstairs, if you got any questions, I'll be ready.
You have to really. Stay. I think about it more like dogs.
Yeah.
It's easier to be like words. I think that that's the actually.
So are the offices
People I saw.
So I feel like that's the only. It's the first Tuesday, that's, you see, that makes sense.
I do probably the right.
So,
Hey, the next section.
well, there could be.
Yes.
First one? Yeah, it's like, jewelry, choose the box, or box, choose the jewelry. Yeah, because that's kind of what's not as.
Not like straightforward, you know? So sometimes I feel like. And I think it's like, there can be some tiny marks, I'm going to.
Yeah.
But one way is.
Which way is it?
And I feel like I have a lot of time.
That takes practice, there's no question about it, but I think it's an example.
And then the slides.
And like.
Which four is
Six.
six?
Six, but then that would just.
That would be six to the four.
Exactly, yeah, that's why I keep getting your call, because you know, that's the thing, I can recognize what I need to know, like, yeah, it's gonna be something to the power of something, but I can.
Yeah.
Sometimes it's hard to identify whether or not what's gonna be my base and what's gonna be my power.
Makes total sense to me,
That's
and
right.
that is challenging, I
And then I
think.
can identify whenever that is the case that we need.
Right. So if it's a physical problem where you can say, yeah, it makes more sense for a person to choose an office, I would definitely try to attack it that way. Because that probably is going to be easier to reason through. We probably could, honestly, we probably could choose this, do this problem differently. We could say, let's let the offices choose the people. And so the first office has, 6 choices, the second office has 6 choices, third office has, but here's the problem. What if the first 2 offices choose the same person?
Right.
You're not allowed to do that. Right? And so. Then, and you can say, well, we'll go ahead and allow it and then we'll subtract violations. But then you're gonna have cases, it's gonna be like, well, if the first 2 offices picked the same person, then the third office would only have 5 people left. Would have 5 people, whereas otherwise, if the first 2. What is best to do is ask yourself, how can I set this up so that the choices are independent of each other? So if I'm choosing office 1, then you can still
You can
choose
still choose
office
office
1 or not, it's your choice, right? But if I'm thinking of it as the office, and the office is gonna, office 1 chooses Fernando, then office 2 cannot choose Fernando, right? So there, the choice that the first office made affects the choice that the second office, I'm not gonna say you couldn't follow through some logic on that and with appropriate adding and subtracting, come up with an answer, but it would be many more cases that would be adding and subtracting nightmare.
I hear you. Here's also my thing for like the common sense part.
Yeah,
Like, I work at a high school and I'm thinking like, okay, when I go into like the office, there's counselors in there. And there's only one counselor in each office. And so that's why my mind went to that. So don't you think like maybe like if on the test it should have more, like even just one sentence of like, multiple people can be.
Oh, to explain it, I will,
Because my
of course,
That's one to that, right? Cause I'm thinking that's the person for office, cause that's, in my head, I experience that every day at work.
okay.
Right?
So it's kind of, so I'll say two things to that. One is when I'm writing the test, I will be more careful than I ever am any other time to make sure the question is clearly written. My second comment is if you read the question during the test and you are a little unsure what should be assumed, I'll be sitting right up there, you come on up and you ask me. And if I feel, never feel like you can't do that. If it's a question I don't think I should be answering for you, I'll just say, I'm sorry, I can't answer that. Okay, you should definitely do that.
The worst that you can get is a no.
Right.
Right.
But I wouldn't make assumptions. I would err on just not making any assumptions that are outside of the confines of what exactly is stated on that paper.
Gotcha.
Yeah.
Awesome.
Okay, yeah, you're welcome.
Well, I'll see you downstairs.
Okay,
Alright.
please,
The first question of like the banquet, stuff.
the fruit.
I was getting confused with the permutation and the multi-set of the combination, like.
Yeah, so imagine that it was 7 different kinds of fruit and you only had one of each. One mango, one pineapple, one banana, one kiwi, one orange, right? Then how many ways would there be for you to eat all those fruits?
Should it be like five, it's like.
Well, there's 7.
They have 7.
Yeah, 7 factorial, right? So the first day I have 7 choices, I pick whatever I want. Second day I have to pick something else. Third day I have to pick something else. 7 and 6 and 5 and 4. Makes sense. Okay, but now instead of 7 different fruits, I want you to imagine that it's 3 different mangoes. Sorry, it's 3 identical mangoes. And it's 2 identical papayas and it's 2 identical kiwis, right? So you could imagine at first that they were all different. 7 factorial, right? And then you can say, well, wait a minute, the 2 papayas are really the same. I could label them as like a P1 and a P2. Papaya 1, papaya 2. If I switch the order of those, it's not like I did anything different, right? So I'm gonna divide out the 2 factorial for that, right? And I'm gonna say the same thing for the kiwi. I have 2 kiwis, so, whichever one I ate, if I ate a kiwi on day 3 and then another one on day 5, it's the same as if I had eaten the actual fruits in the reverse order, but on days 3 and 5. I'm gonna divide by 2 factorial for that. And then the third one is whatever the other fruit was, I forget what it was. Mangoes, that's right. So there you have 3 of them, so you would divide by 3 factorial. It's just the Mississippi problem. 3 M's, 2 P's, and 2 K's. And you're just listing them out. You can pretend first that you really have an M1, M2, M3, and a P1, P2, and a K1, K2. You can imagine you have all that, and that's 7 different things. And then you divide out by the fact that, oh, actually the P's are the same as each other. The K's are the same as each other. The M's are the same as each other. So we get 3 factorial, 2 factorial, 2 factorial, we divide all that out on the bottom.
Oh, okay, but like, at first I thought it was like a stars and bars, so like, it wasn't.
Stars and bars would be that the order doesn't matter. So we're going into the store, we're buying fruit. And that's probably why you thought stars and bars, because of the fruit. But on that grocery store problem, all we said was how many ways are there to buy 18
You
pieces?
should get like how much fruit you wanna get, like.
Correct.
You gotta have like 18 fruits or something.
On this question, it was phrased much more that I wanna know, what did I eat on day 1, day 2, day 3, the order matters. If I eat a kiwi on day 1 and a papaya on day 2, that's different than if I ate the papaya on day 1 and the kiwi on day 2. The minute you're putting things in order, you're not gonna use stars and bars on that.
Okay, I see. I think I didn't like focus on like the A1.
Yeah. So, it's never bad to ask yourself, does the order matter and is the repetition allowed? So on this problem, definitely the order matters and definitely the repetition is allowed. So, normally when you have that situation, you can't, not use the stars and bars for that.
Stars and bars is pretty much combination of the multi set. Right, repetitions allowed.
Correct.
Okay, I see.
Yeah.
Yeah.
Well, I guess I'll see you down there, that way.
Are you going downstairs? There's probably gonna be some students down there, so I'll go down there and I'm gonna be there for a while, so.
Yeah, I'll be down.
If you've got some questions on the homework or just the studying, I'll be there yeah, and then of course, as you know, I'm gonna be here tomorrow too,
Yeah, I'll
so.
be here tomorrow for the. review.
Oops, I